Hi, I'm Bill Cavness with the Asbestos Institute. I wanted to say a quick word about two subjects. Hopefully it'll help you understand compliance and just give you better knowledge of these issues. One is sheetrock, drywall, involved in asbestos abatement. The other is vermiculite, processed vermiculite, involved in asbestos abatement. Okay, just a few quick words about this. First of all, the sheetrock issue. Sheetrock or drywall assemblies have always been confusing under the regulations, especially under the EPA regulations, in dealing with, because they are a layered assembly. It's not just a surface material that's just one material. Or like this concrete that I'm standing on, this cement floor, is a pretty homogeneous material. But a sheetrock assembly is made up usually of 4 or 5 different layers. And let me illustrate that. If I took a knife and I cut a 1-inch square out of this wall, that's what I would send to a laboratory to have analyzed. Oh, and let me caution you, if you're a building inspector, this regulation that tells us how to inspect and sample and get analyzed was not meant to apply to me taking some kind of a scoop and scraping something off the outside of an assembly. It's really meant to apply by me cutting a piece of this assembly out that gives me a clear layered structure and preserving the integrity of that layered structure. Okay, let's say I do that and my sample might look like this. And I'm looking at the cross section of it and it's got various layers. So we'll start at the top up here. We've got a layer of paint. Then we got a layer of wall texture, skim coat or texturing material like we see on walls and ceilings, especially here in the West. And then we'll say there is joint compound, asbestos joint compound. You know how that's used on drywall systems. Then we may have tape, and we may not have tape at the joints of the drywall. And then we've got the drywall itself. And we'll just leave the rest of that for the drywall itself. Now the bulk of the material, because most of these are as thin as this piece of paper, the bulk of the material is the drywall itself. And that's this part. So we have 4, 1, 2, 3, 4, we have 5. We have 5 different materials here. Now the analyst with a microscope will identify these and analyze each one. That's called discrete stratum analysis. And we get a result for each one. Now the result we get is a percent of asbestos, okay, in that certain material. And so our results end up like this. 0 for the paint, 0 for the texture, 2 to 5% for the joint compound, 0 for, well, let's say, well, 0 for the tape. It's a plastic tape. And then the drywall assembly is 0. Okay, gypsum board used in commercial buildings and residential buildings in a commercial way is simply not asbestos. Even before 1980, before 1981, it was seldom used. Asbestos gypsum board was seldom used in a commercial way. In areas like this, in a room where people are, where we find the asbestos containing wallboard was in fire stop areas, in plenums above a ceiling like this, or in fire rated areas like mechanical rooms and so forth, and other products. But in places like this, the gypsum board is just 99% of the time is not asbestos containing. It wasn't made with asbestos added to it. Okay, so this is what we get. Now then we average by our regulatory method, we average the results of each one of these layers and we get a percent by weight of the overall. Okay, so if this makes up the bulk of the weight, and it will, because the rest of those are, like I said, thin like a piece of paper, then our average is going to be less than 1% because the bulk of the material is here. Okay, now this is EPA's analytical method. It's not something that I invented or that you invent. We need to understand the regulatory issue, and then we can go wherever we need to beyond that for our client, the building owner. The upshot of all of this is, under our current printed regulation, where this is the way we analyze, we get a percentage by weight. This is percent by weight. Now that's in the interim regulation that's printed for use in the regulation. There is an improved method, by the way, that would cut out this part, the averaging, and just report on each layer. And if any one of the layers is greater than 1%, then that's regulated. That's called the improved method. And that's like OSHA uses, but EPA has that method also. But this is the one that's printed in the reg. So the application of this is, if the texture is not hot, and I'm saying it seldom is, almost never, regardless of what your lab report has been telling you for years, I'm saying the texture is almost never hot. And if I see a lab report that says it is, I think the lab's in error. That's what I think. Because understanding the dates of application of different construction materials, you would probably come to the same conclusion when things were made by manufacturers here in this country, and when they contained asbestos and when they didn't, when it would be prohibitive for any manufacturer to use an asbestos additive. And that was after 1980. And that's a good safe date. I mean, they just couldn't survive if they used asbestos after that date, because they'd be sued out of existence. And the high-risk materials were all outlawed by that date anyway. But with American manufacturers, I doubt that the texturing material on that what we see on textured drywall systems ever contained asbestos. I think the joint compound always did. In talking to many labs who have analyzed thousands of samples from real layered samples, they would say the joint compound is usually asbestos before 1980. After 1980, of course, it's usually not. The texturing never was. But regardless which side of that you land on, let's just say you take your lab at face value and it says that the texturing is hot. Okay, then the system under the NESHAP regulation for demolition or renovation activities is RACM. If the texturing is not hot, it's not regulated at all, it's non-ACM. So an awful lot depends, regulatory applicability-wise, on the outer texture, if it's hot or is it not. And in a small project, it probably wouldn't make any difference. In a big project, it might make 7 figures or more difference, meaning $1 million or more. So it's important you find out. Okay, the other thing I wanted to mention quickly here in construction activities is vermiculite. And when I use the term vermiculite, I'm not referring to the mineral itself. If I had some vermiculite here in my hand, it wouldn't look like what you think of as vermiculite. It would look like flakes of mica, dark flakes of mica. And that's what vermiculite is. It's a plated mineral, a lot like mica. It's a mica type mineral. So it's not asbestos. The problem is that we have here in the United States is vermiculite is a product that's used in probably 300 different applications or so, horticultural, building materials, all kinds, decorative. And the source of the vermiculite that we use for all these different applications here in this country is mainly from a vermiculite mine up in northwestern Montana. They have supplied over 90% of the vermiculite that we use in this country since about 1950. So in all that time, and they went out of business, by the way, we closed down in about 1990. So for a 40-year period, they mined it all, and they supplied all the vermiculite needs. So when we see a vermiculite product in place in buildings, it probably came from that mine. Okay, that mine is heavily contaminated with asbestos, with an amphibole asbestos contaminant. In fact, it would just as well have been an asbestos mine as a vermiculite mine, but it was a vermiculite mine. The bodies of ore are interwoven so that when the ore is mined, both are being mined. Now the vermiculite companies say, well, when we take that product then, separate it best we can, and then process the vermiculite, it's a process called exfoliation. It's heating it at a high temperature and it actually expands the mineral. Vermiculite has the ability to, under heat, expand or pop, they call it. What looked like a flake or a couple of flakes of mica expands into what looks like a caterpillar. Very lightweight, voluminous, and looks like a little caterpillar. Makes a good insulating material, soil conditioning, all kinds of things. Decorative applications, like I mentioned. And then, when it's expanded like that, it's only the processed vermiculite that we end up with. Well, that makes sense to a point, but vermiculite, the geological conditions under which this mineral develops are also the same for asbestos. So what we find under high visibility analysis like TEM, we find fibers of asbestos, individual fibers between the plates of mica, whether it was naturally formed or contaminated. And then once it's exfoliated, we expect to find contamination in the exfoliated product, and we do to a certain extent. Now, I don't think that processed vermiculite is ever ACM, greater than 1%. But for me to make a statement like that and say it's definitely not, I would have to prove it by analysis. And the analysis would have to be an accepted analysis by a regulatory agency, EPA. Would have to be an approved method of analysis for vermiculite, and we simply don't have that. And EPA has worked with a number of different methods over the years, since about the year 2000, that's 15 years now, and they have never approved an analytical method for vermiculite. So what they end up by saying is, we just recommend you assume positive. In your construction work, your demolition, renovation, home improvement, whatever, it's best if you just assume positive, because we can't be sure about proving negative. Even though they give us a way to prove negative under the regulations called point count. Mechanically, point count doesn't always work. In fact, seldom actually works with vermiculite. Although some labs will point count vermiculite, and you will almost always, if not flat always, come up with a non-ACM analysis by point count. And you could prove non-asbestos that way legally under the NESHAP, but you always have EPA in the background there saying, don't do that, assume positive. Now that's a recommendation, it's not a regulation, but they do recommend assuming positive. So if you assume positive, what you end up with is a friable asbestos material under the NESHAP, which is called rackham. And rackham is required to be removed before demolition or renovation. The Asbestos Institute offices, where I am right now, are in the Southwest United States. We're headquartered in Phoenix. The principal use of vermiculite in this part of the world, and it is a common use other than agricultural, principal use is insulation to achieve an R factor, an insulating factor, in the exterior walls of constructed buildings. Exterior walls built out of CMU block, concrete masonry unit construction. That's just concrete block, you know, with the cells. And once we get the wall up, we fill the cells with processed vermiculite, and it gives us a good R factor, mainly for the heat that we have here in the Southwest. Now in the northern states, they pour it in the attics, and we find it poured in interior walls once in a while. Down here, we see the interior application for sound, acoustical effect, like band rooms in high schools, where the actual wall void would be filled with vermiculite. But usually we see it in the CMU block. Now the problem is, just using our application here in the Southwest, and you can make whatever application you need to wherever you are, but if we're going to demo this building, and it was built with CMU block on the exterior and it has vermiculite in it, we've come to the conclusion that vermiculite is rackham. It's going to have to be removed before demo. I can't really do that. Now, the regulation requires that if you have rackham, you have to remove it all. Not just what's easy to remove or not just what's most visible. You have to remove it all. To leave any of it, spot that big, would be a violation of the standard and a serious violation of NESHAP. So my problem is I could knock a hole in the bottom of every line of cells at different levels if necessary in this wall, and the vermiculite would mostly run out, should drain out, but it's not all going to drain out. I could try blowing it out. I wouldn't get all of it. I would probably get most of it. I could try washing it out, which would probably be a mistake, just like the blowing, because we'd just be spreading whatever contamination might be there. So what I would like to do as a contractor or a building owner is demo the walls with the vermiculite in them. That would be I think, the safest, quickest, most inexpensive, but most importantly, the safest way to deal with this vermiculite. That may be greater than 1% asbestos. I would like to do a controlled demolition, a wet demolition, with the vermiculite in place, bring the walls down, take all the debris to an asbestos landfill. And that might increase the bulk or weight of the debris, and it would with the concrete block. But to me, that would be cheaper and safer than trying to remove the insulation by itself. Well, EPA eventually gave us permission to do that under the NESHAP. In 2008, federal EPA published 2 interpretive rulings that addressed that issue, the concrete block with vermiculite. And they essentially just said, because of certain considerations, we give you permission to do the demo with the vermiculite in it. You don't have to remove any of it. But all the waste is regulated because we're assuming that it's ACM and it is friable. So that makes the waste stream regulated, which is what we wanted to do to start with. And so it worked out well for us that way. The only thing that would work out better is to be able to prove definitely that vermiculite is non-ACM. And personally, I don't believe that it is as vermiculite, but it may be contaminated beyond that percentage level. Now, just one last cautionary statement. You need to check with your regulator in your delegated jurisdiction or your regulated area what it is that they want you to do, because some states in the country have taken a very hard line with vermiculite, and some states just assume that it's asbestos-containing material, and they regulate building materials based on how much vermiculite is in the product or on the product, just assuming that it's ACM. A very hard line with vermiculite. So you need to check with your local jurisdiction and find out. Now, those are my comments on troublesome issues like sheetrock and whether it's regulated or not, and vermiculite and how it's regulated. Thank you.